Welcome back to the channel. So last time we finished up the valve nut, and the valve rod, and then we finished up the eccentric strap and the ring. So now we need to make a pin to connect these two together. So we need to make a pin that'll go in there. So I've got a 1/8" piece of steel here, and then this is going to get turned down to 1/16, and then just have a button on the end and then a hole for a cotter key. So we'll get that turned down. And I've got a scrap piece of brass here that we're going to turn down for the inlet to hook a air hose to, and then we'll make a piece. I've got an 1/8" piece of brass. I've got some tubing that I'm going to try to thread for the exhaust here down on the bottom, or if that doesn't work, then I've got a solid piece of brass that will bore out, an 1/8" piece of brass rod that will turn threads on for 540 and screw into there. So we'll get this set up in the lathe and get started on this pin. Okay, so I got the inlet and the exhaust made and installed. This is just turned down to 540 on the end. Then it's made to fit the hose size that I have on my regulator. And the exhaust here is just a brass piece turned 540 and drilled out 1/16 there. Doesn't really matter what that looks like or what the dimensions are on that. Just something that'll fit. Then I got the pin made for the eccentric strap. I think that's the smallest pin that I've ever made. It's 1/16 pin and then a 1/8 inch on the head. And that's so that's 0.62 on the shaft. And then the hole there is 0.33 drill. And I used the lathe, my lathe crotch center to make that, to drill that hole. If you haven't seen that video, it's in the playlist for the tools, and that thing worked really good. That's hard to drill a hole that small in the center of a pin like that for the Carter key. So it'll take a split Carter key like this. These are 1/32 Carter keys. So that worked really good. You don't have to set anything up or do any edge finding. Just put this in the center in your tailstock and then put the drill in the headstock and then drill your hole through. So we'll get this pin installed here. And then we'll make sure we're adjusted right and everything's working right before we actually put the Carter key in there. So we'll go over the initial settings as I have taken this back apart and put the packing nuts in here. And then once I had it apart, you want to set it to where the piston has equal travel, where it stops at top dead center and bottom dead center. So you want the distance between the end of the piston and the end of the cylinder to be as close as you can get it to the same on both ends. And then for the valve, let me get this cover off. So you want to adjust this. You want to turn this valve rod here and adjust it in this nut so that you're getting approximately the same amount of travel uncovering the port. So you can see there that that hole is fully uncovered. And if we turn it, then you can see that that hole on the other end is fully uncovered. So you want to center that valve between those two holes and the length that it travels. So in order to adjust it, just take this pin out and take this loose and then turn this valve and adjust it, and that'll move the valve. Turn this rod, rotate this rod, and that'll move the valve back and forth and get that adjusted. So we'll go ahead and I'm happy with that adjustment to start with. So we'll go ahead and put the cover back on. And that's why I do like doing studs in this instead of bolts, especially for this steam chest. It makes it easier to take this cover off and everything else stays in place while you're adjusting that valve. We'll get these nuts back on and get them tightened up. And then we'll go over adjusting the eccentric valve, or the eccentric position on the crankshaft. And then we'll be ready to put some air in it and see what it does. It's probably going to leak air out some, because I haven't made any gaskets yet or anything, and we need to put some packing in there around the valves, but we'll just make sure everything's going to work first. So we'll snug these nuts up here. Okay, so we've adjusted the position of the piston, we've adjusted the position of the valve. The next thing we need to do is set the eccentric in relationship to the crankshaft. So if you read through the plans, it says to rotate the piston to where it's either at top dead center or bottom dead center. So that's top dead center there. Sorry, bottom dead center there, top dead center there. So you can do it on either end, and then depending on where you adjust the eccentric to will determine whether it's going to run clockwise or counterclockwise. So whichever end that you want to set it on, bottom dead center or top dead center, with this connecting rod horizontal, as horizontal as you can get it. So somewhere like that. Then we want the axis of this eccentric to be 90 degrees from this line. So we drilled our set screw on the axis. So you want to put the set screw facing directly up when this is horizontal. And if you this was set to run in the, looking at it from this side, this will run counterclockwise. If we rotated this crankshaft to here, to top dead center, and then if we moved our eccentric, you can see that our set screw's on the bottom, but if we moved our set screw to the top, then it would run the same. It's just that this would run clockwise in that clockwise direction if you set it that way. So we've got our set here at bottom dead center. Set screw is at the top. So we'll put a little bit of oil in the cups and hook up the air line and see what happens. We'll give it a little bit of oil on everything. And we'll hook up our air line. Then I've just got a simple regulator here and an on-off valve. And then just a regulator that I can set the pressure there. Hook this directly into my air line. All right, I got it on, plugged in. I'll turn it on now, give it a little bit of air. And it's running. That's about 20 PSI right now. So I can see we're leaking a little bit of air around the cylinder head there. And sounds like and feels like we're leaking a little bit of air around the packing nuts. I'll give it a little more pressure. That's 30 PSI. Everything seems to be working like it's supposed to. It's running good. Looks like it's the flywheel set screws come loose. So everything is working like it should, running good, but it is leaking air, leaking a little bit around this cylinder and around the packing nuts. So I'm going to tear this back apart and make some gaskets for it, and then I have some valve packing that we're going to try. This is 3/32. It's the smallest stuff that I could find. If anybody knows of a source of some smaller diameter stuff, I'm not sure where to find that, but I got this at the local hardware store. So we're going to cut some of this and put it around the packing nuts, and then we'll make some gaskets, and then I'll bring you back and we'll see if we can get it to run at a little bit lower PSI with it leaking less air. Okay, so I got gaskets made in between all the steam chest areas here and redid the packing. Got everything put back together. So let's give it some air and see how it runs now. Oh yeah, that's much better, much quieter. It was definitely leaking a lot of air before. Still leaking just a little bit right there on that fitting. That's not bad. That's running at about a little less than 5 pounds, maybe 2 pounds, something like that. So that's much better. We still got just a little bit of a leak there on that packing nut. I'll have to tighten that one up a little bit more. But I'm happy with everything, how everything turned out. So hopefully if you were following along and building one, that you got yours running good. See how low it'll go before it stalls out. It's about 1 pound. It's not even reading on the gauge. That's about as low as I think it'll go. It'll probably stall out if I go much lower. Okay, so to answer the original question when we started this is, can you machine and make the Elmers number 33 horizontal mill steam engine just using a lathe and a drill press? So I think clearly the answer is yes. I did use the milling attachment, so I don't know how you would do it without a milling attachment, but if you've got a milling attachment for your lathe, it's entirely possible to make this engine using just a lathe and a drill press with a little bit of creativity on some of the fixturing and stuff to get everything made. So that's going to do it for this episode. We will continue one more episode I do want to make a pulley for this. I like to have a drive pulley on my engines just to make it look more realistic. So we'll machine up a pulley on here. And then I have a wood base. My dad is working on a wood base for this that I'm going to mount it onto. And then we'll take everything back apart again. That's one thing with model engine building. You get really used to taking it all apart and putting it back together. So we're going to take it all back apart one more time and prep it for paint. So we'll primer everything and then paint it. And then for this base down here, I've got an idea that I want to try, because I do want to make some lines in here to make it look like a tile floor. But we'll get to the fit and finish on all of that and make the pulley next time. Thanks for watching.